For today we are looking at the 9 times table, so that's multiplying and dividing by 9. I'm going to go through this PowerPoint with you and then you can work through the questions on your own at the end. Make sure you have some pen and paper with you at the moment though, because I am going to ask you to make some notes as we go along. Okay, our starter today, I would like you to write down all the number calculations you can think of for this array. So pause the video and write down those multiplication and division sentences. Let's go through the answers. So how many counters do I have in a row? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 counters in a row. And how many rows do I have? 1, 2, 3, 4 rows. So I could say that I have 4 lots of 9, or 4 multiplied by 9. I could also look at this as columns going down. So I've got 1 4, 2 4s, 3 4s, all the way along I have 9 lots of 4. So you could have written those number sentences. 9 times 4 is 36. Or 4 times 9 equals 36. You could have also written the division sentences to go with this. So we know our whole number, our total, is 36. That's how many counters we have there altogether. I could divide my 36 into rows of 9. So if I group them together, that is one group of 9 that I've made. And then I've made another 3 groups of 9. So altogether I have 4 groups of 9 that I can make with my 36. So I could say 36 divided by 9 equals 4 groups. I could have also divided going down as my columns. So I could have divided my 36 by 4. I'm dividing it into groups of 4. So how many groups of 4 can I make? I can make 9 columns of 4. So those are the division sentences that you could have written as well. Give them a tick if you manage to get all of those correct. Okay, now we're going to have a look at this question. Complete the missing numbers. There are something number of cookies. There are something chocolate chips in each cookie. And there are something chocolate chips all together. So let's look first of all at that first one. How many cookies do we have? I've got 1, 2, 3, 4. 4 cookies. How many chocolate chips in each cookie? So that's asking me how many chocolate chips on one cookie, because they each have the same. So how many on one? There is 1, 2, 3, 4, 5, 6, 7, 8, 9 cookies, 9 chocolate chips, on each cookie. And I can check that for each of them. There is 9 chocolate chips on each cookie. So how many chocolate chips have I got all together? Well, we can use our number sentences to help us. 9 add 9 add 9 add 9. You might write that out, or you could even draw that as a bar model. When we add 9 together 4 times, we get the total 36. So we know that there is 36 chocolate chips all together. But remember, we are trying to be efficient mathematicians. That means we try to make the quickest, easiest sentences that we can. So instead of writing out all those additions, we could write that as multiplications. Can you pause the video for a moment and write down the multiplications that could fill these boxes? Okay, so you might have written 4 times 9 equals 36, or 9 times 4 equals 36. Because remember, we can swap those factors over and keep the same product. And the product means our answer. I now have this question. Each packet contains 9 sweets. Imagine inside each of those green packets there is 9 individual sweets. I would like you to pause this video and complete this number sentence. What are we adding together? Just look at that one for the moment. Pause the video. What did you get? Hopefully you realise that because there is a box for each packet of sweets, you are adding together the 9 sweets each time. So I've got 9, add 9, add 9, add 9, add 9, add 9. So you can work that out. I've worked it out for you. That is 54 sweets. But remember, we are efficient mathematicians, so you are able to write this nice, quick, concise multiplications. So I'm going to give you a moment. You can pause if you need to write down the multiplication sentences as well. We have 6 times 9 equals 54 and 9 times 6 equals 54. The number track at the top shows us the 9 times table. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99 and 108. I want you to have a think about the patterns you notice about the 9 times table. And to help you, I'm going to turn our times table sideways. Now we can have a closer look at the ones column and the tens column, because I've lined all the numbers up. Let's look at the ones column first. I start on the number 9. And let's move down and we'll see what you notice about the ones column. 8, 7, 6, 5, 4, 3, 2, 1, 0. Now our ones column is decreasing by 1 for each multiplication. Decrease, remember, means getting smaller, going down. So our ones column is decreasing by 1. Let's have a look at our tens column. We start with no tens, so 0 tens. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 tens. So our tens column is increasing, getting bigger by 1 for each multiplication. I wonder why that is. Why do we think that it's going up in the tens and down in the ones? Well, that's because instead of looking at this as the 9 times table and adding 9 on each time, we're going to look at it as 2 steps. Adding 10 and then taking away 1. Because adding 10 and taking away 1 is the same as adding 9. But this way it's really easy to see why those numbers are changing. So 9 add 10 is 19. But remember, we want to do the 9 times tables, so we have to take 1 away. 19 take away 1 is 18. And we can look at this for some other examples. 36. If we add 10, we get 46. And if we take 1 away, it gives us our next multiplication in the 9 times table, which is 45. Does this work for all of our 9 times tables? Let's have a look at some of the bigger times tables. So I've got 11 times 9, which is 99. To find 12 times 9, can I use this rule? 99 add 10 is 109. Take away 1 is 108. So this does work for all my numbers in the 9 times table. We need to remember when we are solving questions on the 9 times table that to find the next number in a sequence, we have to add 10 and take away 1. This will give us the 9 times table. Another really useful trick is this magic hand rule that we can use for the first 10 times tables in the 9 times table. Yeah, so we've got 0 times 9. Well, we know that 0 times anything is going to be 0. So we can sort of skip that one. And then we're going to look at 1 times 9. Now, I want you to count 1 finger on your hand. And once you've got that 1, you are going to put it down. Okay? However many fingers you have left wiggling on the right hand side of that finger that's down is your ones. So how many ones do I have? I have 9 ones. So the answer to 1 times 9 is 9. Let's have a look at 2 times 9. So you get your fingers again, and you're going to count 1, 2, and you're going to place the 2 down. Now this time, any numbers, any fingers that are wiggling on the left-hand side, you're going to count as 10s. So how many 10s have I got? I've got 1 wiggly 10. And then on the right-hand side, we're going to count these again as 1s. So how many 1s do we have now? We have 8 1s. So I'm going to put those numbers together. 1 10 and 8 1s. My answer to 2 times 9 is 18. So let's look at this again for 3 times 9. You're going to count 1, 2, 3 on your fingers and place that one down. How many wiggly fingers and thumbs do you have on the left-hand side? You have 2. So they are 2 10s. How many wiggly 1s do we have on the right-hand side? We have 7. So we're going to place that as the 1s. That means the answer to 3 times 9, and remember, we know which one we're doing because we put that finger down. 3 times 9 is 27. And this works for all of our multiplications all the way up to 10 times 9. Because all the way up to 10 times 9, we're going to put our 10th finger down. How many 10s do we have? We have 9 10s and no 1s. And after that, sadly, we run out of fingers. But you can use this to help you with any multiplication in the 9 times table that is below 10. Finally, we are going to solve this question. What numbers are missing and how can we work them out? Well, we're looking, this meter stick is showing us the 9 times table. But that first number is missing. Well, this is 1 times 9, which is 9. So what must our first number be? What do we start on at the very end? It's 0 times 9, which we know is 0. Because anything times by 0 is 0. Now we can move on. We have 1 times 9, which is 9. 2 times 9, which is 18. 3 times 9, which is 27. But now, our fingers moved along. We have 4 times 9, but it's missing. You might know your 9 times table off by heart, which is fantastic. If you don't, there's a few ways that we can solve this now. I'm going to look to the next number, because I know 5 times 9 is 45. I know my 5 times tables really well. So now I know that 5 times 9 is 45. To work out 4 times 9, I need to take 1 lot of 9 away. Because if I've got 5 lots of 9 and I want 4 lots of 9, I just need to take 1 lot of 9 away. So I could calculate the answer by doing 5 times 9, which is 45, take away 1 lot of 9. So 45 take away 9 is going to give me 34. And that has solved 4 times 9. And now I can keep going. 5 times 9 is 45. 6 times 9 is 54. 7 times 9 is 63. 8 times 9 is 72. 9 times 9 is 81. 10 times 9 is 90. But then we're stuck again. There is another gap. This time, instead of taking away from the next number, or the next multiple of 9, I'm going to look at the 10. 10 times 9 is 90. If I want to find 11 lots of 9, I can just add on 1 more lot of 9. So 90 add 9 is going to take me to my next multiple, which is going to be 99. And then we can finish our line, which is 12 times 9, 108. So how do we work those out? We can either add on 9 to find the next number, or take 9 away from the number that is next to jump back to that previous multiple. Okay, I would like you to now work through the questions on the PowerPoint. If you get stuck, you can look back at this video or you can check with the audio buttons that I've put onto the PowerPoint. These will give you some extra clues about what you need to be doing or how you can do these at home. When you're finished, you can check the answers on the answer sheets which are online, or you can send your work to me and I will mark it for you. I would love to see how you're doing, so make sure you send me some photos of what you get done.